This is the schematic we received in our kit for the receiver module. And this is the schematic we received for our transmitter module.
We purchased our kit offline and chose the unassembled one so we would be responsible for all the soldering. The kit consists of two boards, the transmitter and the receiver, and each had several components on them including resistors, capacitors, and diodes. In our kit there were so many different components that we were not sure where they all fit. David explained to us how the different stripes on each resistor signified its total resistance. From that we were able to determine where each one went on each of the boards. Here was David's explanation of the color coding on all the resistors. This chart represents the number that's associated with the color bands on each resistor. For example, in this resistor, the total resistance would be 4,491 ohms. Here is our receiver board, about halfway completed.
Here's our receiver board finally completed.
We did not have the power supply for our board because the one supplied only worked in Europe. David gave us two 5-volt adapters which we cut to get the ends off and then used a breadboard to get the required power supply for our project, which in this case was 12 volt center positive.
We did an infrared security beam, and we got a kit offline where we actually soldered it and put up all the capacitors and pieces together on the circuit board here. And Aaron will tell you more about that in a sec, but I'll just say basically how we hooked it up. It didn't come with a power adapter or anything, so we kind of had to custom make our own. What we got here is it runs off 12 volts, so we have a 12 volt breadboard, and what we did is we took two 5 volt adapters, cords. They actually fit, and that'll make it work. And we cut them off and attach them to the breadboard, and then that allows us to actually plug in and power both the transmitter, which is this one, and this one's receiver. And so that's how we powered it.
The 555 timers on the transmitter board were the most important parts of our project.
Alright, so on the transmitter board, like Aaron said, we have the two 555 timers, and what they do is they modulate the frequency that comes out of the infrared beam, and it comes out at 38 kilohertz. And the reason it does that is because you have so much like infrared interference that it broadcasts on that specific frequency almost that this board knows that the receiver board knows exactly when the beam is tripped, so they can set that off.
After our initial test, we found that the receiver board was not functioning properly. We took a voltmeter and tried to find the faulty component. The board was getting power, but for some reason when the beam was tripped, the relay was not switching over. After we could not get the receiver board to work, we decided to resolder just about everything to make sure we had a good connection. By the way, the solder sucker is the coolest thing ever. Alright, got it right there. Get it. Ah, it soldered it. It's all you right there. Nice.